Good morning. If we want to talk about the cardiovascular system and the heart as a pump, then we need to talk some about the amount of blood pumped per minute by the heart, or cardiac output. In order to do that, we need to first talk about the amount of blood pumped in a single beat, or stroke volume. Next, we're going to talk about cardiac output and how it relates to stroke volume. And finally, we're going to look at a metric that helps describe how well the heart is pumping, and that's called ejection fraction. Let's start with stroke volume. Stroke volume is the amount of blood the heart pumps in a single beat. And it can be calculated by taking the amount of blood that starts in the heart and subtracting what's left when it's over. To get a visual, let's look at a left ventricle. We're going to measure output from the left ventricle. I'm going to say this 100 milliliter cylinder is the left ventricle. When the heart's at rest, the ventricle is filling. So blood flows into the ventricle while it's at rest, which is called diastole. And at about 100 milliliters, let's say the heart has completed rest, that's in diastolic volume. The fullest of the left ventricle will be. When the heart beats, it's called systole. And when the heart beats, blood is ejected from the ventricle. And at the end of systole, we have an end systolic volume, which would be the lowest volume. In this case, that reads about 30 milliliters. So we started with 100 milliliters, ended with 30 milliliters. We must have pumped 70 milliliters out in that heartbeat. And if I look at the scale, I know that 1 milliliter of water has a mass of a gram. I'm looking here and we have a mass of 71 grams that I poured out. So even ballparking, we're awfully close. Well, if I pump 70 milliliters of blood in one heartbeat, and if I have two heartbeats, then I would pump 140 milliliters of blood. So again, in diastolic volume, in systolic volume, and I've pumped about 143 milliliters of blood. So stroke volume is in diastolic volume minus in systolic volume. That gives us the amount of blood that was pumped out of the heart in a single beat. The amount of blood that's pumped out in multiple beats is the number of beats times the stroke volume. Often we're going to talk about flow of blood from the heart as cardiac output, the amount of blood the heart beats in 1 minute. At rest, my cardiac output might be 5 liters per minute, and it can go well up over 20 liters per minute during exercise, 25 liters per minute during exercise. So we can look at this, but we're going to have to get rid of that item and look at this item. And unfortunately, even this item isn't going to be enough, but it will be since my heart is not very functional. And what I'm going to do is start my watch with a 1 minute timer and measure the amount of water I pour in a minute. I'm going to start at an end diastolic volume of about 100 milliliters per minute, end with an end systolic volume of about 40 milliliters a minute. So the stroke volume would be about 60 milliliters per minute, and we'll see how many times I get that done in 1 minute. Okay, I only got about 10 heartbeats in there, and the first one was I poured out way too much. The stroke volume was too high. I tried to make up for it, but about 10 beats in a minute. So if my end diastolic volume were consistently 100 milliliters and end systolic volume were consistently 40 milliliters, then the stroke volume would have been 60, and I would have pumped 10 times 60, or 600 milliliters in a minute. That's 1/6 of a liter per minute. So that can give you a feel for how effective our heart really is. If at rest it's pumping 5 liters per minute, That would be about 100 beats per minute if the stroke volume is 50. For point of reference, this pot is about a 5-quart pot or 5-liter pot. So my cardiac output at rest would fill this pot every minute, which isn't bad for a little pump dumping 60 milliliters at a time or 50 milliliters at a time into the pot. We can use some information about stroke volume to get a feel for how the left ventricle is functioning. Again, if this cylinder is our left ventricle, it's filled to 100 milliliters to start. At the end of a heartbeat, there are, in this case, 35 milliliters left. Then end diastolic volume minus end systolic volume is 65 milliliters. So the stroke volume was 65 milliliters. We started with 100 milliliters in the cylinder or in the left ventricle. Then the fraction of blood pumped out of the heart was 65%, 65 milliliters over 100 milliliters. That's known as the ejection fraction. And you could imagine that if I had an ejection fraction of 65%, oh, that turns out to be pretty good, just fine. But imagine I had a left ventricle that started with 100 milliliters and ended with only 80 milliliters. Then the stroke volume was 20 milliliters. The ejection fraction is 20%. That's not a very effective left ventricle. So the lower ejection fraction in this case indicates poorly functioning left ventricle. We can use ejection fraction to get a feel for how the left ventricle functions with the blood that it starts with at the end of diastole. So let's summarize what we've talked about today. First, stroke volume. Stroke volume is equal to end diastolic volume minus end systolic volume, or the volume of blood after the heart's finished filling minus the blood that's left in the heart after it's finished contracting. Whatever that difference is must have been pumped into the arteries. Next, cardiac output. Cardiac output is the amount of blood pumped each beat times the number of beats in a minute. This gives us the amount of blood pumped into the arteries each minute. And then ejection fraction, which is the fraction of blood in the left ventricle that was pumped in each heartbeat. And this gives us a metric for left ventricular function, or how well the heart is working.